continuously at 8%.
No question. You give us the formulas for this class. Whenever we go on to higher math, do you still get the formula? So none of these.
I mean, yes, it depends on the formula. It depends on the class.
So like these, and for the section that you've given us this class, you'll give us all these, right?
Sure. Yeah. Okay. Am I doing any like bait and switch on you? We've worked from similarly worded, right? Is this an exponential growth problem? That was the key phrase here, right? And Tara's saying, you'll give us the formulas. Fair enough. But if I was giving you a formula, what formula would you be expecting? Would you use this formula? Would you use this formula? Would you use this formula?
The second one is continuous, right?
The keyword was continuously compounded, right? Now here's the thing. I'll give you these formulas. And you're saying use that formula? Why not that one?
Are we looking for both, right?
What about these is different? The letters. Alright, what's the principle? In general. It's how much you start with, right? What's y sub 0? How much you start with, right? What's r? Your interest rate, your growth rate, right? T is time, T is time. This is how much you have, how much you have. This is just a special case of this formula. It's the same formula. I'll still give you both, but it's worth pointing out that they're the same exact formula with different letters, right? So, here you go. I gave you one number, and I gave you the only number you need to answer this question. How long does it take for your investment to double? How much did you invest? It doesn't matter, right? The only thing that matters for double times is the growth rate, right? So how long would it take for your investment, your principal, or whatever you want to call it, to grow if the interest is compounding continuously? So we're using one of those two bottom equations or formulas at 8%. So what does this look like to you? Okay? Alright, now Trisha maybe kind of sort of skipped a step. And I'm cool with Trisha skipping that step, because this is where we're going to ultimately land. What if you're uncomfortable with that, or what if you're unsure about that? Did you want to actually start with something?
If you put the p or y sub 0, you're just going to divide it off.
Right. If you start with some principle, and you double that principle, when you divide both sides by p, they're both gone. And you end up with what Trisha gave us. Right? So, how do I solve this equation? Well, yeah, the calculator is a wonderful and powerful tool, but it's not our savior. Right? We have to tell the calculator what to do, so we're going to take the natural log of both sides. And I actually kind of do that before I touch my calculator. I don't know. Because I know something that my calculator doesn't always know. I know that the natural log and the base you cancel. Remember when we asked what's the natural log of e to the 247th power? The calculator said, I don't know. But we knew it was 247. John?
Why does the natural log cancel e?
Because the natural log is the log base e. Right? And it's... Alright. So the natural log of 2 equals 0.08 t divided by 0.08.
You round up.
Well, what's our time probably measured in? What kind of interest rate is this?
A year.
This is an annual interest rate, right? So our time is probably measured in years. Could you have 8.66 years? Could you have 0.66 of a year? We only measure time in exact 1 year increments. You don't do half of a year? Like you were never 3.5 years old. Sure, you can have 0.66 of a year. It's, you know, it may come down to months and weeks and days and stuff like that. But yeah, I mean, we can break up our year into other stuff. But I'd say about 8.66 years.
So if we wrote 8.66 or almost 9.
Well, that's not almost 9. That's only 2/3 the way to 9.
You wouldn't let us round up? You wouldn't want us to?
I would not want you to. In fact, I kind of felt cheapy just giving you 2 decimal places. I probably should go to 4 and 3.